say that this is. Okay, here we go. So, welcome back, guys. Ladies and gentlemen. What we have here is a bolt hole circle. And a couple of ways to do this. One, you get a large indexer, do it on a milling machine, on a conventional mill, or you program it on a CNC mill. Either way, you would have to figure out the X and Y coordinates of all the holes. Now, when I say X and Y, if you look at a milling machine from the top down, you're gonna have X-axis, Y-axis, and negative being on the bottom and on the left-hand side here. The center of the part would be considered the origin, which is right here. Okay? So what's going to happen is you got this part, this block of metal, aluminum, whatever you're making, is going to be 25 inches by 25 inches square. And you have to drill 6 holes through this part on a conventional mill or a CNC. What I normally do is I do what's called a setup sheet. 3, 4, 5, 6, X, and Y on all of these. Okay. And the objective is to plug in the X and Y coordinates for all these holes so that we can actually drill them out. Right away, I could see that there's a couple of holes that I can plug in without doing any kind of math. What does it say here? It says bolt hole circle is at 19-inch diameter. Give X and Y for all. Okay, so if it's a 19-inch diameter, the radius is what?
8 inches.
8 and 8 is 16.
Oh, wait.
That's not correct.
9.5.
Yeah, 9.5.
Huh?
9.5.
9.5. So that means that the distance from the center to the outer hole that's straight up is 9.5 inches, right? And this is our number 1 hole, by the way, number 2, number 3, number 4, number 5, number 6. I can go counterclockwise, I can go clockwise. I selected to go clockwise with this part. All right, so my number 1 hole, I immediately could plug in my X and Y coordinates, right? Anybody tell me what they are?
1 is
X is
9.
0, Y is 9.5.
So X is gonna be what?
0.
0.0. Y is gonna be what?
9.5.
9.5 because it moves 9.5 inches in the positive direction, right? Yes? Are we all tracking this so far? All right. So we got 9.5. Now, number 2, we need to, and the whole reason that we're doing this, guys, before we even get any further, is because our machine, our conventional machines only move in 2 directions. They move back and forth this way, which is X, in and out this way, which is Y. If we program this on a CNC, we'll put both numbers in there and the CNC will automatically go there. We'll take the shortest route to get there. But we're not robots, so we have to go there by X-axis and Y-axis to get there, okay? So our number 2 hole has to go over and up or up and over to get there. Number 3 hole same thing, down and over or over and down. But our number 4 hole, it goes straight down. That's kind of like our number 1 hole, right? So can we plug in our number 4 hole coordinates?
Yes.
Okay, can you tell me what they are?
X is 0.0 and y
X is
is
0,
and y is negative 9.5.
negative 9.5. All right? Hopefully everybody's understanding this, right? We're on the negative side. Anything, by the way, this is negative, positive right here. In this quadrant here, we have negative, negative. In this quadrant, we have negative, positive. And in this quadrant, we have positive, positive, right? Okay? Hopefully you're understanding that. So again, this whole negative on the y, not moving in any direction on the x. So that's why we put 0. All right? Those are the 2 holes that were easily plugged in, but the rest of it has to be calculated. So how do we go about calculating this? Well, I'm going to erase this. And what I'm going to do here is I'm going to draw a circle somewhere on this thing. So I can get it just right. I think that's good. Again, if I can see it visually, I can do it easier. So that's why I do this. So now, if I draw a line straight down, and I know it's kind of crooked, but it's straight for me. And right over with this, over with this. I'll draw a line from here down, and draw a line from here over. What did I just do? I just created 2 right angles. And we know we have 6 holes. If we take 6 divided by 360, or I'm sorry, 360 divided by 6, what do we get?
60.
That's correct. So we go 360 divided by 6 equals 60, and we're talking about degrees here. So that means that the distance from hole to hole in angle shape, or angle, is 60 degrees. Right? 60 degrees. Now, if I make 2 right angles, and forgive me for my uneven drawing here, but these angles are both the same here. My angle from here to here, well, if I know it's the total of 60, so half of that would be 30. And again, if this is 30, I try to plug in as much information as I can. We know that the other side automatically becomes 60. Why? Because between those right there, between those 2 right there, between angle A and angle B, they have to add up to 90. So I can plug in 60 degrees right there. Now, what other information do we have to work with here?
The hypotenuse. Say it again.
We have the hypotenuse, which is the length of that angle, which is really the radius, right? We can plug that in. That is, and by the way, let's make a right angle over here. We're going to say we got 60 here, we got 30 here, and we also have across the hypotenuse, which is equates to the radius of this diameter. What is it? 9.5, right? 9.5 inches. Yes?
Correct.
Now, I've said this before and I'll say it again. There's a general rule of thumb with 30-degree angles. Do you guys remember what it is? Anybody? Brian. What's the rule with 30 degree? If we know little c, which is right here, by the way. Right?
Little a is half of that.
That's correct. Little a is half of that, so that's going to be 4 3/4.
475.
4 4.750, yes?
Yeah.
Okay, all I did was I divided this by 2, or vice versa. If I have little a and it's 30-degree angle, I automatically know little c. Right now, I could start plugging stuff in over here, because we got, I'm gonna say at least another 50–60% of our problem solved. But let's just continue and finish it. Now, if we know that, anybody know the formula for figuring out little b? Which is the base? Little b equals little c squared minus little a squared, and you square root the whole problem, right? So how do we go about this with our calculator? We're gonna say little c, 9.5. We're gonna hit that button, the square root button, or the square root button. Then we're gonna hit the minus button. Then we're gonna hit the, then we're gonna plug in the numbers of little a, which is 4.750. Then we're gonna hit the square button again. We're gonna hit equals, and then we square root the whole thing out. So that would be the process with your TI-30XA. And I'll write this TI-30XA calculator. Is what I use. And I'm not trying to give them a plug or anything, guys. I just been using this for many years. It's worked. They're relatively inexpensive. I think you pick them up at Walmart or Target or wherever. $11, $12, I think. So they're pretty good, and they're reliable, and they last a long time. I think I've changed the batteries in them every 3 or 4 years. They do have a solar one too, by the way. Same exact one, but it's solar. And those batteries last about probably 8 or 9 years on those. Okay? So now, anybody get my answer for little b, by the way?
8.2272.
I'm sorry, loud and proud. A little bit louder.
8
inches.
8 inches, 227,210.
8 inches, 200. Does everybody agree with that?
Yep.
Yes.
Good. Okay, 8 inches, 227,002 if we're on a CNC, CNCs read 4 place decimals with no problem. If we're on a conventional machine, forget about those 2 tenths, okay? But if I was to program this job, I definitely will add the 2 tenths on a CNC machine. On a conventional machines, omit it. That means drop it, take it out, okay? We're pretty much resolved our problem here. All we gotta do now is plug in our numbers. So we're gonna go to number 2. We're gonna say X, how far over does it have to go? From here to here. 8 inches, 227,000 to the positive direction. 8 inches, 227. And I'll go ahead and put it in 2 tenths just for the hell of it. In the positive direction, all right? And the Y, how far down do we go? Or how far up do we go from center?
4 and 750,000.
4 inches, 750. And that's also in the positive direction. Now number 3, how far over? We're gonna do X before we do Y, right? How far do we go over?
8 inches, 227,000.
8 inches, 272. Again, it's kind of redundant, but it is what it is.
Positive.
And how far down do we go?
-4.75.
-4.750 this time. We got a negative number because it's on the negative end from here down, negative, right? Or I should say, wait a minute,
Correct.
yes, Y is negative. And number 5, gonna go over, X,
Negative.
negative
8.2272.
8.2272, and my Y negative 4.750, negative, right? And finally, number 6. Negative
Correct.
8 inches, 2.272, and Y, positive 4.750. Now we have our setup sheet. Ready to go. Okay? So we're good. Any questions on this, guys? Okay, thank you so much.